robinreaction.com. In this video, I'll be going over the differences between pure substances and mixtures. And so, first we're going to go over some definitions and this chart on the left, and then we're going to do practice problems. So let's start off with the very top of this chart, which is just all matter. So matter is basically what the entire universe and Earth and everything you're going to see in your life is made of. There are some exceptions. Some things that you're going to see are made of energy. That's mostly light or heat. However, things that you think of as things that you can pick up and carry, all of that's made of matter. And so within that matter, we have our first two categories, which are pure substances and mixtures. And so now we have to start getting into actual atoms and molecules to understand the differences between pure substances and mixtures. So the very first thing we're going to look at is elements. And so elements are just what's on the periodic table. There's a limited number of them. You can look them all up just by looking at the periodic table. And what that means is that you have one type of atom. And so you don't have any bonding of different atoms to each other. You don't have any more complicated molecules. You don't have more than one type of atom. You have one single type of atom on the periodic table. And so that's one type of pure substances. And the other type is just a compound. And so in this sense, compound really means molecule. What it means is that you have a chemical bond, usually it's going to be ionic, metallic, or covalent, that's making multiple atoms come together to form a molecule. So in this case, you could think about it in terms of H2O. So you could say, okay, the blue is actually going to be the oxygen in this case, and then each purple is a hydrogen that the water is bonded to. So those are our two types of pure substances. And the main thing we can just see is that there's only one type of thing, right? Either you have one type of atom or you have one type of molecule. So in our example for a compound, every single one of these molecules is an H2O molecule. We don't have a secret salt molecule hiding in there. We don't have a secret other type of element hiding in there. So if we had all these H2O molecules and then we had one atom of just oxygen by itself, that still wouldn't be a pure compound because we wouldn't have the same type of molecule for every single thing. All right, so now just to get into this definition, pure substances, one type of atom or molecule, it's all the same thing, and it has unique physical properties. So what the physical properties means are things like what temperature they boil at, or what temperature they freeze at, or their density. And so your teacher may go over another list of physical properties that pure substances all have. But basically, it's just kind of a definition thing, where these pure substances have certain things where you can look up in a textbook and say, hey, we know that water always boils at 100 degrees Celsius. That's just a fact about water. So now we're going to go over to mixtures. So these mixtures come in two types, homogeneous and heterogeneous. And so we can see just from these little pictures what's going on and the differences between them. So homogeneous, our first one, is where everything is completely mixed together evenly. We can see already, as opposed to our pure substances where we just had either red dots or blue and purple molecules, now in the mixture we have an orange and we have a green. Now it doesn't matter what these things are. These could be atoms, these could be molecules. What's important is that they're completely evenly spread around. So if you were to look in here and try to say, oh, is there an area with more orange or with more green? The answer would be not really. And if you average out all of the areas, it's pretty much going to be completely blended. Now, yeah, we could go like this and say, oh, this square just has greens. But really, when we look at the whole thing, we can just kind of visually see it's blended together. That's not really separated. Versus heterogeneous. So in heterogeneous, the main thing is that we have two or more things, but they're physically separated. So if we were looking at this, we could say, oh yeah, there's this clear area where we have this one type of molecule, and then we have this one type of atom down here. We can clearly see there's a division. And so the definition for all mixtures are a random blend of two or more substances. Both of these examples have two things in them. You could easily have more, right? It's not a mixture. It's not like it's not a mixture. If you mix 5 things together, that's still a mixture. It's just at least 2. And then it has no unique physical properties. And what I'm talking about there is the same things that we were doing for pure substances. So basically, if we're saying that these mixtures don't all have the same density or don't all have the same boiling point or melting point. It's going to depend on what the mixture is made of. And then another thing for this is that we could have a mixture that's 50-50, we could have a mixture that's 60-40, 90-10. So it can't have these unique physical properties because there could be many different variations of that mixture. All right, and then the last one is that it can be physically separated. And so what that means is that with mixtures, you can do things like you can filter them out. If you had a mixture of sand and water all mixed together, you could just filter that. And you can do other type of lab techniques where you can actually separate these things, whereas with pure substances, you can't really do that. You can't separate water from water in a meaningful way. You can cut it in half, but that's not like a separation technique, right? If you are going to break apart a pure substance, you're going to have to actually do chemistry and break and form these bonds that keep these things together. So overall, that's our definition. And now let's go ahead and just get into practice problems. All right, so here are 6 different things. We're going to break down if they're pure substances or mixtures, and then even farther into what type of these things they are. So, starting with aluminum foil, if we check the periodic table, we will see aluminum there. And there's actually nothing else that aluminum foil is made of. It's just pure aluminum. And so that means that it's a pure substance. And then even further than that, we're going to say it's an element. All right, and next, let's do air. Ignore the balloons and the clouds. This problem is just talking about what air is. And so air is not 100% oxygen, which is what we breathe. It includes nitrogen and several other gases. And so this is definitely going to be a mixture. But when you think about breathing, it's not like sometimes you take a breath and, oh, I got a ton of oxygen in that breath. And sometimes you take a breath and you didn't get any oxygen, right? It generally feels about the same each time. And so that's because the air particles are completely mixed around evenly. And so we'd say that this is a homogeneous mixture. All right, next we're talking about dirt. So we look on the periodic table, there is no dirt element. And if we kind of stare at dirt, we can see it's not exactly one thing. If you're staring at dirt, there's going to be little hard pockets, little darker and lighter spots. And so we know it's going to be a mixture. Dirt's definitely not just one type of molecule or element. And also, it's going to be a heterogeneous mixture. It's not completely evenly broken down. There are places where you can clearly see, okay, there's different things going on here than there are here. So next, water. This is our example from earlier. Again, ignore the air bubbles in this picture. We're just talking about water. So water is made of H2O. Every molecule of water that exists is made of H2O. There is no other version of water. So we'd say this is a pure substance. And we'd also say it's a compound. There's no water element on the periodic table. All right, so next we have steel. So we look at that, and there is no element called steel, and you wouldn't necessarily know if it's a compound or not until you knew a little bit more about how you make steel, but it's actually a bunch of different metals melted together and they form steel overall. So steel is definitely a mixture, and it's a homogeneous one, right? When you look at a piece of steel, it looks like a piece of steel, not a ton of differences between 2 or 3 inches down on a chain link or a plate of steel. And last, we have pizza. And so this one is pretty clear, right? It's definitely not an element. That'd be cool though. It's not a compound. It's definitely a mixture. And it's going to be heterogeneous, right? We can clearly see that different spots exist. It's not all the same consistency. All right, I hope this video cleared up the differences between pure substances and mixtures for you.
Hey, I hope you liked that video. Please feel free to like, comment, or subscribe. And if you go to my website, I have a ton of free practice problems you can check out. And if you need even more help, you can hire me for one-on-one private tutoring sessions that are online. All right, thanks, that's it. Happy studying.